Hello students, today we are going to start with graph second lecture. A path in a graph. A path in a graph is a sequence of vertices such that from each of its vertices there is an edge to the next vertex in the sequence. Like in this diagram, we can show path from A1 to A5 in different ways. A1 to A2, A2 to A4, A4 to A5. It's a path. There's different paths from A1 to A5. We can reach A1 to A5 through A1, A3, A4, A5 and like that. See, in this diagram I have shown 4 different paths. Path 1 is A1, A2, A5. Path 2 is A1, A2, A4, A5. Path 3 is A1, A3, A4, A5 and path 4 is A1, A3, A4, A2 and A5. So there are different types of paths. First one is simple path. In simple path, no edge is repeated. That is, all the vertices are distinct except that first vertex and the last vertex. Next one is elementary path. In elementary path, no vertex is repeated in the path. All the vertices should be distinct. Third one is circuit or closed path. In circuit or closed path, it starts and ends at the same vertex. That is a circuit. It forms a circuit. In simple circuit path, in the graph which shows a simple path as well as circuit is known as simple circuit path. Now in this diagram, I have shown different questions. First is simple path from V1 to V6. There are multiple paths. V1 to V6, V1, V2, V3, V4, V5, V6 and like this there are multiple paths, multiple simple paths. No edge is repeated. In elementary path, no vertex will be repeated. V1 to V6, V1, V2, V3, V4, V5, V6 and like this so many different paths are there. In a path which is simple and not elementary from V1 to V6 should be V1, V2, V3, V5, V2, again V4 and V6. In this, V2 edge is repeated. That means it is not elementary. Fourth question is a path which is not simple and starting from V2. So, in the diagram, you see V2, V3, V4, V5, V3, V4 and V6. Again, next question is a simple circuit starting from V1. Then it should be V1, V2, V4, V6, V5, V3 and V1. Starting and the ending vertex will be same. And the last question is a circuit which is not simple and starting from V2. That means vertex will be repeated. V2, V3, V1, V2, V5, V4 and again V2. So I have given a question also. I will share with you. Now I'll show you some different types of graph. First one is null graph. In null graph there is no edges. A graph which contains only isolated nodes is called a null graph. That is, a set of edges is in null graph is empty. Such graph on n vertices is denoted by n. For example, null graph n4 with 4 vertices is shown as like this. 4 vertices. Next one is complete graph. A simple graph G is said to be complete if every vertex of G is connected with every other vertex of G. That means all the vertex are connected to each other. Every pair of distinct vertices contains exactly one edge. It is denoted by Kn, where n is the total number of vertices in G. I have shown 4 different types of graph. K1, only a single vertex, isolated vertex, is also a complete graph. K2, 2 vertices are there. K3, 3 vertices are there and all the 3 vertices are connected to each other. K4, 4 vertices are there. All the 4 vertices are connected to each other. Okay. Next one is regular graph. A graph in which all the vertices are of same degree is called a regular graph. If the degree of each vertex is r, then the graph is called a regular graph of degree r and it is denoted by r. For example, this is a 2 regular graph. All the vertices, there are 4 vertices in this graph and all the vertices are having same degree. Like in this, V1, V2, V3 and V4. V1 is having 2 degree, V2 is also 2 degree, V3 is also 2 degree and V4 is also 2 degree. So, a 2 regular graph with 4 vertices. A complete graph Kn is a regular graph of degree n-1 or it is called as n-1 regular graph. Okay, again there are 2 questions. I'll send you that questions. Now it's multigraph. A graph which has loop or multiple edges for the same nodes can be described as a multigraph. Like in this graph, A, B, C, 3 different nodes are there and there is a self loop on the vertex A. That means it is a multigraph. In this diagram, A, B, C, D, 4 different vertices are there and in A, C vertex, there are 2 paths, A to C, C to A. It's a directed graph.